Handscape is an orientation-aware digital tape measure that can be used as an input device to capture field measurements and graphically visualize the volume of the resulting vectors on a computer screen. It looks like a regular measuring tape, but it also consists of a custom-made circuit board, which includes a magnetic sensor hybrid and an accelerometer, which together provide the orientation information. So when the user moves it around, Handscape is aware of its own direction and tilt. To transmit the current measurement, the user simply pushes a button, and through RF transmission, the data is sent from the handheld tool to the base that is connected to the host computer. Efficient use of space for packing, storing, and transporting goods is vital in the industrial sector. As demand on space and distribution operation increases, investing in material handling and storage equipment to improve efficiency, profit margins, and reduce distribution and storage costs becomes crucial. Imagine a whole room of boxes that need to be packed into a storage space. Space optimization is usually a multi-step process involving measurements and calculations done by hand. However, with Handscape, the whole process can be completed with simple one-step interactions by the user. The user only needs to measure the dimensions of each box. As this is done, graphical representations of the boxes appear on the screen and the best packing configuration is determined. Handscape can also be used to rapidly model and visualize 3D objects in interior spaces. Arranging furniture in interior spaces can be a cumbersome task if there is no preformed plan for where everything should go. If a user had representations of his furniture in a digital domain, it would be easy for him to move them around and lay them out before physically moving the objects around. Handscape can be used to create these representations. All people would have to do is measure the objects and the distances between them. Once digital forms of the objects have been attained, they can be easily manipulated. An archaeological excavation is examined and documented primarily using handwritten measurements, notes, and photography, which are often irreplaceable during the on-site excavation. With Handscape, the user automatically defines the layout of the excavation on the laptop. In a reference frame, 3 additional measurements are taken. These are used to define a cubic figure in the virtual space that represents the location of an artifact in the physical excavation. As three-dimensional spacing is an important factor in analyzing archaeological work, Handscape provides an advanced step towards linking the physical archaeological excavation with a virtual rendering. This could integrate on-site and laboratory archaeological research. As we have shown in this video, the addition of orientation sensing has given Handscape the capability to increase the efficiency of several real-world applications, namely ones that involve on-site measuring tasks. We have also learned that without the need to learn and adjust to a new interface, making use of existing physical skills preserves the human senses and interactions that are commonly employed in everyday life.